Alright, so like we did with the sine and cosine graphs, it turns out that we're also going to be transforming our tangent and cotangent graphs. So the equations will pretty much look similar, but rather than sine and cosine, we have tangent and cotangent. Alright, and so the A, B, D, and C are all going to impact our tangent and cotangent graphs. Again, A causes a vertical stretch or compression. C causes a vertical shift up or down. And B causes a change in the period, and I'll talk more about that in a moment. And then D causes a phase shift to occur, right, from our actual motion. However, since we're not experiencing wave-like behavior, some of the language we use, like amplitude being what A was, and phase shifts and equilibrium shifts, that language doesn't quite come into play here because of the way our graphs look, right? Again, remember tangent from negative pi over 2 to pi over 2 is basically looking like this, right? And cotangent from 0 to pi, from 0 to pi, is basically looking like that. Okay, so amplitude makes no sense here because there's no height of a wave. And then phase shift doesn't make any sense because our period's not even 2 pi. We're not going through a full rotation. And then the equilibrium shift's a little hard because we're not really, I guess you can kind of think of it as an equilibrium because part of the graph's up here and part of it's up here, but we're not there's no wave action going on. So we don't really call it an equilibrium shift. But what we can do again is A causes a vertical stretch or compression. And this is almost irrelevant because these things are going to positive and negative infinity anyways. So, if I was to take, let's say, 5 times a tangent of x, all that's going to do is just stretch this graph out even more. So it's going to make it skinnier. Or if I took 1/5 tangent of x, that's just going to make this a little flatter in here, but it's still going to go to infinity. So seeing A is not real easy to do. C, that one's a little easier to do because what's going to happen is we shift things up or down, right? What's going to happen is the equilibrium shift, if you'll notice that if we did think of the equilibrium being along the x-axis, if we shift this up and down, that vertex, that x-intercept is going to shift up or down. This is going to shift up or down. So we can kind of almost see where that S shape starts to occur, right? So we start, we're concave down and then concave up. If we were to shift that up, right, we'd expect to see that going on. So the x-intercepts are going to basically shift. As a matter of fact, we lost the x-intercept because we're no longer crossing the x-axis, but that's still somewhat equilibrium shift-like. What is also new is since the period is pi, the new period is that old period pi divided by b. So that's slightly new here. And then of course D, we know, shift things horizontally left or right, but we're not technically calling it a phase shift because we're not a wave. So pretty much the same idea is going to occur, right? To get one period of action, right, what we're going to basically do, right, we're going to do our multiplications and divisions first, right? So we're multiplying by A and dividing by B, right, for X and Y. And then we do our additions and subtractions next, right? So that's basically how that goes. And for a tangent graph, again, for one period from negative pi over 2 to pi over 2, oops, this is x and this is y, we broke it into negative pi over 4, 0, and pi over 4. And we had asymptotic behavior, right? This was a negative 1, oops, that's a positive 1, and that's 0. So we're basically going to be manipulating that. Those are the core data points on a tangent graph that we're going to basically, oops, as I realized I was off the page there. So here's our core points in a tangent graph. For a cotangent graph, right, the core points for cotangent of x, we start at 0 and go to pi. That's where the asymptotic behavior is going to be. And then we broke it up into pi over 4, pi over 2, and 3 pi over 4. We were 1, 0, and negative 1 respectively. So if we can manipulate the data with the A's and the B's, the C's and the D's, then we can manipulate one period of our tangent graph. And if we can graph one period, it just keeps going on in that fashion forever and ever. So it's all about getting that first period. So again, you're going to see me doing something very similar in the next couple of videos where we just manipulate data points, draw our sketch, and we're done. If the book asks for a couple of things, just repeat it one more cycle and you're finished. Right? But I think I'll just be asking things for just one cycle just to make things simple for us. Alrighty, so let's get to work. Let's go transform some graphs.